Alright, so now begins my demo of the first mini project. As you can see, I used the U.S. News College Statistics data, which tracks a number of variables across 777 colleges across the United States of America. The variable you're currently seeing is the number of applications each college received. As you can see, the overwhelming majority received between 81 and 6,083, with only one over here receiving quite a few more. I believe that's Rutgers in New Jersey, very big college. Anyways, you can switch variables being seen. I just switched over to the percent of alumni who donate to a school. As you can see, most schools have somewhere in the range of 10 or so to 40 or so percent of their alumni donate, with a few very close-knit schools having more, and a few very disconnected schools having less. Now, of course, you can click on this and transition into a pie chart. Rebinning works for all types of graph: pie chart, bar graph or histogram, and force-directed graph. I'll show you now a rebinning of the student-faculty ratio bar graph. Reduce the number of bins here. As you can see, there's outliers on this side, smaller number of outliers on this side from boutique schools with small student-to-faculty ratios, but most schools are in this general area. Anyways, now I'll move on to the force-directed graph. Now, the way my force-directed graph works is every one of these represents one of a randomly selected 10% of the approximately 10% of the data points. Each one is connected to a bin, with the bins being determined the same way they are in histograms or pie charts. And very close values are also connected to each other, like these two. Now let's see if I can't find a more interesting force-directed graph. See, this one is one of the ones where it's dominated by a small cluster. You can see subclusters here and here. This is a more diverse array of data points with lots of little clusters that are mostly separate from each other. Another similar one. And you can see the subclusters really nicely in this one. This is one of the ones I was looking for. As you can see, you can not only see subclusters, but you can also see transitions between different bins. For example, this bin, which has this range right here, has a subcluster here and here, but it's also very closely connected to this bin, with the values sort of blending between each other. Cluster here, you see, and here. This tells us a lot more than histogram can, because it can show transitions between bins, distinctions, sort of subclusters as well. If there's a cluster within a bin, you'll see it here, but you might not in a histogram or a pie chart, unless you reduce the size of the bins. And of course, rebinning does work for these. You can see lots of interesting information, estimated book costs, various clusters. Some schools spend more on books, some schools spend less. And of course, graduation rate is always interesting. You can see the better schools with high graduation rates around this area, and the worst schools with minimal graduation rates. They tend not to last very long. This is an above 100% graduation rate. I looked into that. It is actually due to new students enrolling, I believe, because the rate only takes into account freshmen, not transfers. So if you get a lot of transfers, you can get a graduation rate above 100%. Anyways, so going back over it, force-directed graph, clusters, bar graph. Each bar can be highlighted. You can see the outliers and the bulk of the data. Pie chart. You can also see sort of the distribution, split it up into more sections or fewer sections. And of course, transitioning back to bar graphs, you can rebin here too. Alright, hope you enjoyed my demo, and have an excellent day.